Hello everyone. Today we are going to learn about big omega asymptotic notation under the subject algorithm. So this is the symbol we use for writing big omega notation. So what we will learn today, what is big omega, why big omega is used, and we will see one example on big omega notation. So what is big omega? Omega notation represents lower bound of running time of an algorithm, exactly opposite of big O. Big O was used for specifying or representing upper bound of running time of an algorithm, whereas this is used for lower bound, means how less time algorithm is taking to execute. That is notified using big omega. So it provides the best case time complexity of algorithm or best case space complexity of algorithm. If your algorithm is taking very less time and space to execute, then you can notify it or write it down using big omega notation. So it is used to represent best case of an algorithm. Now this is the equation written like this for big omega, f of n equal to omega of g of n. Now this is a graph I've drawn to show you big omega, how it works. Same way like big O only, horizontal axis is n, which is the input axis. We have to give the value for n, and one value n naught will be the breaking point. From there itself, no change in the value in the values of f of n, g of n will become. Means f of n will be always higher after some value of n naught. F of n will be always higher and g of n will be always lower. It will never change. It will never get opposite. That g of n will never become higher than f of n. Before that point, that before that specific n naught value, it will change. It will keep on changing. Like n, at some point g of n will become higher. At some point f of n will become higher. Again g of n will become higher and f of n will become lower. But after one specific point, when the value of n naught will become some, it reaches to some value, no, n naught will get some value. After that value, no, f of n will be always higher and g of n will be always lower, and c is a constant. So now this is the equation. C of g of n is less than equal to f of n. Or you can say f of n is greater than equal to c of g of n. This is the equation for big omega, exactly opposite of big O. Here also c should be greater than 0. It is a constant. If you don't take c greater than 0, f of n will be greater than equal to 0. It will be 0. Okay, and 0 doesn't have any value. So c should be always greater than 0 and n naught value should be greater than or equal to 1. If this equation becomes true, if this condition gets satisfied, that is f of n is greater than equal to c of g of n, then only we can write that f of n is big omega of g of n. Only if this is correct, then only. If this is coming false, then we cannot write it as f of n is omega of g of n. So now why big omega is used? So in computer science, big omega notation measures functions time or space complexity. So this means we can know in advance how well or best the algorithm is performing in specific situation. It is used to notify best case of any algorithm. How best your algorithm is performing, that you can notify or represent using big omega notation. So it is used in computer science to describe the performance or complexity of any algorithm. So now we'll see one example on big omega. This is a question given. Find out whether g of n is equal to n is asymptotic lower bound of f of n equal to 5 of n square. Now you have to find the lower bound. That is the best case. And f of n will be always higher in this case. So firstly, we'll take the value of n as 0 and we'll check what is happening. When n equal to 0, f of n will be what? 5 into 0 square. That is 0. And g of n will be what? 0 only. Then we'll take n equal to 1. When we take n equal to 1, f of n will become what? 5 into 1 square, that is 5. And g of n will become what? 1. When we take n equal to 2, f of n will become what? 5 into 2 square. So that is 20. And g of n will become what? 2. When n equal to 3, f of n will become what? 5 into 3 square. That is 45. And g of n will become what? 3. If you see, f of n is always almost 5 times greater than g of n. So it will never come down. If I show you using graph, you will understand that f of n will be always greater than g of n in this case. So if you see n equal to 0, then n equal to 1, n equal to 2, equal to 3. So when n equal to 0, f of n is becoming what? Both are 0. F of n is also 0, g of n is also 0. When n is becoming 1, that time f of n will become 5, and g of n will become what? 1. Okay, it will become 1. When n is equal to 2, f of n will become 20, and g of n will become what? Just 2. Okay, so this one will keep on increasing and this one will be always lower as compared to f of n value. So g of n will be always lower than f of n, because when you take n equal to 3 also, g of n will be 3 only. But see f of n is becoming what? 45 over here. Whenever f of n is greater than c of g of n, this f of n is greater than or equal to c of g of n, we say that what? F of n is big omega of g of n. Okay, and here c is what? 1. C equal to 1. Okay, so 1 into n it is doing every time. So this way you can find out whether f of n is big omega of g of n or not, if like this type of examples are given, by drawing the graph and by taking the value of n. Now here you can consider n naught value as 1. So if you see n naught 1, it will never change only. It will never change. It will remain same. And f of n will be always greater than c of g of n. So this was an example on big omega. So this big omega notation is always used to tell the best complexity of the algorithm, or best time or space. If any algorithm is giving, then it is notified or represented using big omega notation. Just remember the word best case and lower bound. Thank you.